Welcome to Unite Now, where we bring unity to you, wherever you are.
Hey folks, so this is going to be a Unite Now presentation covering the Universal Render Pipeline, specifically evolving your game's graphics using that render pipeline. This presentation is going to cover a wide range of different use cases and scenarios with the Universal Render Pipeline, and a couple of example projects that are going to be available for you to download pretty much right now. My name is Andy Touch. I'm a global content evangelist at Unity Technologies, and I'm based in the Unity Copenhagen office. And a lot of my job is around working with R&D team, product managers, product marketing managers, and getting to use a lot of the features Unity's developing and build example projects, content, tutorials, and things like that to teach how Unity is used. So these are a couple of topics I'm going to cover. The first one is a quick overview of the scriptural render pipeline direction and ethos, and also the universal render pipeline. These are both relatively new features in Unity's history. So I want to focus on these and sort of give a quick overview of what they actually are and why you would actually use them and how you can actually make the most of the settings that universal render pipeline comes out of the box. I'm then going to cover a couple of other areas. One is the foundation, such as the render pipeline asset. And this is the core functionality of any project that uses the universal render pipeline. The next is a recent feature. So this was released last year in 2019. And these are scriptural renderer features and also custom passes. And these are a very unique and very powerful way that you can actually inject custom effects into your project and custom passes. You can achieve some very interesting game results and game effects by using these. The next feature I'm going to cover is camera stacking. And this is very new, but also highly requested by our community and our users. And this allows you to take multiple cameras that are rendering and stack them and render certain content to them, basically compositing a frame of multiple cameras as opposed to just one camera. And this is quite typical of pretty much any game of such a scale, where they would have different cameras rendering different forms of content. I'm now going to give a quick overview about future features. So these are features currently in development and also going to be going into development very, very soon. So let's give an overview of the scriptural render pipeline. This is a core focus of Unity's graphics team, and it's a C# rendering API layer. What that means from this diagram is we have Unity C++, which is controlling the core and various elements of rendering of Unity. And up until this point, we've had the built-in renderer, which has had both deferred and forward supported and covers a wide range of different uses. And what we asked a lot of developers is what they would want us to focus on in graphics. And a lot of them wanted to focus on a couple of things. One is custom rendering solutions. They want to be able to extend the renderer, able to implement their different concepts, different effects, different results, different things they want to achieve. And with the old built-in renderer, that was a little tricky, partly because it was a bit of a black box. And there was a couple of different things which were quite old. So what we wanted to do with the scriptural render pipeline is create a new C# rendering API layer, which allows you to extend, dig into the source, which is available publicly. If you go to github.com/unity-technology/graphics, you'll be able to get the source of script render pipeline and also the tools that come with it. And users wanted to be able to dig in and modify and customize and basically be able to extend and create their own different custom systems and results. So it's a C# rendering API layer that sits on top of Unity and can be plugged into and modified. Now, in creating the scriptural render pipeline, we also wanted to offer our own Unity-developed rendering pipelines with different purposes and different focuses. One of these is the universal render pipeline, and the other one is the high-definition render pipeline. And if you've seen some of our videos or keynotes or blog posts, you've probably seen them mentioned quite a lot. We're investing heavily in them, and they're going to be very core and integral to pretty much any graphics feature being developed in the future, or currently developed now. Systems such as Shader Graph and VFX Graph are built on top of these render pipelines and are hooked and directly working with them So when you download these render pipelines, you have the shader graph system and the VFX graph system, plus lots of other tools at your disposal. Now, the universal render pipeline, which is what this talk is going to focus on, is focused covering a wide range of different platforms. It's built for cross-platform development, it's built for performance, and it's also built so you can customize and stylize the rendering, as you'll see later in this webinar. The high-definition render pipeline is a little bit different. It's more for the high-end devices, such as consoles and high-end desktops. And this one is focused more on realistic graphics and rendering. And if you've seen our demo projects such as The Heretic, Book of the Dead, Fontainebleau, these are all built using the high-definition render pipeline. So we have these two render pipelines, and they have slightly different uses. They do have some overlaps, so Shader Graph and VFX Graph work with both of them with some slight differences. And we also have other systems such as post-processing volumes, which also works with both render pipelines in slightly different ways. So even though we're developing these two different render pipelines, and they do have their own different sets of features, there is some overlap in functionality. So what specifically is the universal render pipeline? The focus covers a wide range of different areas. It focuses beautiful graphics, and we're not trying to dictate whether you want to create a realistic game or a toon shaded game or a 2D game. We basically want to expose a lot of graphics tools and functionality so people can create kind of any sort of type of game that they want or type of project. We're also focused on performance. So it's a continuation of the lightweight render pipeline, which is being developed for a while. And the lightweight render pipeline was, and I say was because it's been renamed and set up to be the universal render pipeline, was focused at performance. How can we take these shaders and these lighting system and post-processing, make them as fast as possible? And what we noticed is a lot of users wanted to use the lightweight render pipeline and have that performance, but also have that wide platform reach and be able to create beautiful graphics. So we've evolved the lightweight render pipeline into the universal render pipeline to kind of cater for that wide range. And the universal render pipeline is going to be the foundation for future rendering in Unity. So when you start a new Unity project, or if you want to just get started with 2D or AR or VR and things like this, universal render pipeline is basically going to be the place that you want to start with. So it's focused on graphics, and you're not limited on what you create. You can create 2D pixel art if you want to. You can create toon shading if you want to. You can also create high-end graphics and also performance. The next point is platform reach. So universal render pipeline works on any platform Unity currently supports. And it's also key to extensibility, and I'll show you a little bit that later on. Whilst the universal render pipeline offers a variety of tools directly outside of the box, directly in the box, sorry. You can also extend it and modify it and create your own custom scriptable render passes and different render features and things like that. So we tried to create it so that you can extend it and modify it. A lot of core systems are updated automatically, so there is an upgrade tool. So if you do have your project and you take it from the built-in renderer to the universal render pipeline, I will warn you, it is quite a destructive process, and it's destructive in that you're basically upgrading your project, and usually when you upgrade it, it's difficult to downgrade it afterwards. So a lot of the materials and pretty much all the core vanilla shaders that come with Unity can be upgraded to use the universal render pipeline's shader libraries and built-in shaders. However, manual upgrade is required for usepass or shader.find. These are a couple of old APIs, and actually some of the tools and systems I'm going to show you a bit later on in this webinar is going to cover some of these use cases. So there are some old APIs which aren't currently supported out of the box, or aren't supported in general out of the box, and you will have to manually upgrade them to use universal render pipeline's new systems. Another benefit is it's supported in Unity 2019.4 LTS, and that's long-term support. And we're really core focused on the universal render pipeline and making sure that it is as powerful as it possibly be and covers a wide range of different platforms and uses. So as I mentioned before, it supports a wide variety of platforms, pretty much everything Unity supports right now. And you can see everything from mobile all the way to console, such as Nintendo Switch, PlayStation 4, Xbox, also to VR, such as Oculus, and also AR, such as Magic Leap AR Core and HoloLens. So if you're developing for one of these platforms, which I'd probably say you most likely are, then your Universal Render Pipeline works on these systems. You can use it today. So before I jump into Unity Editor, I want to cover an example project that's been developed for a while using the Universal Render Pipeline. And it originally was developed using the Lightweight Render Pipeline, but it's evolved with the Universal name change and Universal evolution. And I want to cover a couple of facts about this. So this project's called Boat Attack, and it solves a variety of different problems. It's a project developed in-house. So it's developed by one tech artist developer, and it's focused on production-driven development. So it's a vertical slice of a real-world boat racing game, and it's targeted at a range of different platforms: desktop, mobile, and consoles. And it was created to be a complex testbed for a variety of new features. So as we develop new features and systems using Universal Render Pipeline or Unity in general, then basically, rather than a simple test such as a spinning cube or some bouncing spheres and things like this, it was developed as a vertical slice. So we can implement different features and systems and see how they work in this project. And it's useful as a learning resource both internally and externally. Internally, so our developers can kind of use it as a proof of concept in a test and be able to iterate and experiment with different systems in a game scenario, but also external because the project is actually public and you can download it right now. And I'm going to share a link at the end of the presentation. And it's supposed to be representative of what a small dev team can produce. So there's one tech artist developer who's created this project, and he's embedded into our R&D graphics team. And he has help from that graphics team and a couple of other people to be able to develop and maintain this project. He's been developing it for quite a while, and it's basically evolved over the years and over the months. So Boat Attack has a wide range of features, both Universal Render Pipeline features, so it heavily uses shader graph. It also has a wide variety of different custom shaders, such as water and things like that. And it also uses some custom rendering features, such as planar reflections on the water, so you can see the rocks reflecting on the water surface. And basically, it's a nice sort of marriage of a wide variety of different features and systems Universal Render Pipeline has. It probably uses about 90% of URP's features. It also uses a wide variety of other Unity features. And this is to test relationships between systems and also stability in code compiling. So as you race around the track, you have text floating above the boat's head, the boat's bodies, as you can see in this GIF here. There's also physics being used, the new input system, audio. It's basically testing a wide range of different features and making sure they all work very nicely together. It's basically a one-person dog fooding example project. And he also uses vanilla packages that are not customized or modified, and vanilla Unity binary. So it's using 2019.3, and there's a variety of different branches. So it's not a custom build of Unity. It's being developed basically in-house using the tools that are available to you today. So it's using public custom tools for gameplay and public custom tools for utilities. In terms of shaders, they wanted to test a wide range of different uses and see how much control they can have. So shader graphs are used for a wide variety of these rocks and different elements, including the boats. Geometry shaders are also used, compute shaders as well for water and things like that. And they're highly complex uses. They're not something basic such as a gradient. They're basically shaders that cover wetness of rocks, or displacing the water, or having sort of tessellation as you move the camera around for the water in the environment. So the demo usage is more scenario based for a game like this. And if I jump out of the slides and jump over to Chrome here, what you'll notice is that there's already a blog post written by the developer Andre on this project. And as I scroll down, he's covered a wide range of uses already, which I won't be going into specifically into this demo. And you can obviously read this blog post and learn from his different uses and download the project as well. He also goes into great detail how the planar reflections are implemented and also how the caustics are implemented for the water. So if you're curious on how to create water for your projects using Universal Render Pipeline, you can download this project, extract the water, and extract the knowledge for your own uses. So I'm now going to jump over into Unity and show you the project in the editor. So the project is an island, and it's a single racetrack that goes around this cluster of rocks in the middle. Now if I enter play, you can basically see that there's a lot of different systems and features being used. Of course, I'm going to turn this off. So timeline is being used to sequence using Cinemachine, this sort of camera intro like in a typical racing game. Some boats have been spawned, and now I can control it using WASD. We're also using UI to render a minimap, some lap times, and there's just lots of really pleasing things that are being rendered in this project, such as the water, these checkpoint gates, the rocks, and all the different environment pieces around the outside, including the cloud layers here. Now if I leave play mode, let's have a look at how a lot of these systems are being controlled in assets. So when you have the Universal Render Pipeline installed, and that's installed from the package manager, you basically get these render pipeline assets, which look like something like this. You create this render pipeline asset, which you can do from the project window, so project rendering Universal Render Pipeline asset. And this gives you a wide range of different features and systems that you can turn off, turn on, and control. So for example here, I could sort of disable and re-enable HDR mode. I could turn off anti-aliasing. I can also disable shadow rendering in the project. You'll notice that the blue that pops up is the shaders refreshing. I could also control things such as like shadow resolution. So if I get up close, I can switch it and lower the shadow resolution. You get a lot of global settings and effects that are all available to you here. And the way that BoatAttack works is underneath project settings and inside quality, you'll notice that there are 3 quality settings: low, medium, and high. And this has been in Unity for ages. This is nothing new. But when I switch between low, medium, and high, just wait for the shaders to refresh. As you can see, they're refreshing at the bottom right hand of the editor. If I switch to medium and then high, you'll notice that the shadow quality and shader quality is changing. And that's because each of these quality tiers has a render pipeline asset slot. So you can actually set up these different render pipeline asset settings for different types of quality settings. So we can go low quality, medium, and high, and set these to different platforms. So you can not only create a render pipeline asset to control your shadows, control your lighting, and things like this, you can also hook this into Unity's quality setting system. Another interesting part about BoatAttack is that all the lighting, or a lot of the lighting, is actually real time. So if I select this cameras option here and move this time of day slider, you'll notice that a directional light will rotate around the world, basically casting different types of lighting. So we can go from nighttime to dusk, to dawn, to the middle of day, and all the way around to dusk again. And notice all the lighting is adapting and changing using these settings. So using the Universal Render Pipeline, you can, and targeting mobile and things like that, you can not only use sort of real-time lighting in different setups, but you can also adapt it and change it in your project. So you don't have to necessarily bake all the time. You can actually have the power of using directional lighting and still get impressive graphics and visuals. Another key component of BoatAttack is shader graph. So shader graph was used to create and design the different environments. So if I take this rock and then move it around, you'll notice that as it moves in and out of the water, this water line is forming at the bottom. And as I move the rock up or move it around, this triplanar shader is basically calculating that grass should be rendering on top of the rock. So as I move the rock's position up, the grass is then going to adapt accordingly. So using Shader Graph, the one developer was able to create a couple of these rocks and then basically set dress the whole environment and be able to litter the rocks all around to create this level without having to retexture them constantly. You can use Shader Graph to create some really interesting, powerful effects. And the next thing we can cover before I jump into scriptable render features is the water. So the water is using a custom system built for this project, but you can extract it and put it in your own projects if you're using Universal Render Pipeline. The water has lots of different settings and tools. You can switch between vertex offset and also tessellation for the water geometry type. You can switch between cube map for the reflections, so it's a pre-baked cube map. It doesn't look as nice as assigning a reflection probe or even planar reflections. And it's using Universal Render Pipeline's features to be able to have planar reflections as the camera moves around. So notice with this rock here, we've then got some reflections that are taking place here. And you might be able to notice it if I play around with water visibility. So if I lower the water's visibility and tweak these settings, you can notice that we have these planar reflection rocks that are happening, and also these clouds in the sky here. The water also has some settings for not only how it renders or what it's hooked into, in this case planar reflections, but also things like the wave settings. So I can actually adjust the water's swell amount, set that back. I can also change the swell height, so how high the water is. So you basically get a lot of interesting tools and systems to be able to allow you to sort of control how the water is rendered and how the water is basically rippling throughout the environment and how it intersects with the edge wall as well. There's lots of interesting things to dissect with this water shader and this water system. And in the blog post I showed you earlier on, and I link at the end of the presentation, it goes into more specifics and details on how a lot of these systems are created and used. Now I'm going to set the lighting back to something a bit more middle of the day, and then I'm going to switch back to my slides. So I'm going to cover the first sort of features or systems, and that's scriptable renderer, features, and custom passes. Now, Universal Render Pipeline was designed with the render flow with modularity in mind. So with modularity, it means that you can have the typical rendering loop and camera loop, as you can see here, so such as the beginning of the frame rendering and the end of the frame rendering, and all the steps in the middle, such as culling and things like that. But you can also extend it. You can inject your own render passes and additional features. So rather than it being a black box and you can only inject, say, post-processing, you can also hook into camera callbacks and access the camera data and be able to inject them and basically add different effects and systems into your projects. And with these render effects, you can also set up, using camera data, custom rendering. So for example, you can create an effect that renders after the opaque pass, but then before the transparent pass. Or you can create an effect that uses the depth pass data and then applies it in like a water pass or a caustic pass. And that's basically kind of what Bodatak is actually doing to render the water. It's created with modular rendering, and you can extend the Universal Render Pipeline without source modification. So you can actually do this by downloading the Universal Render Pipeline package and setting your project to use it. And then straight out of the box, you can then start to extend the Universal Render Pipeline using these scriptable renderer features. You don't have to then modify the source. Of course, you can modify the source if you want, because we've made it available. You can inject in custom effects and use data from the camera renderer. And these are all viewable and debuggable in the frame debugger. And the custom renderer asset is built up of a couple of things. One is the renderer settings, such as layers and things like that, and the other is the render feature list. So I'm going to jump over to Bodatak and show you a couple of different systems and tools. So if I go to the render pipeline high asset, and let me just check that I'm using this one. So I'm selecting the high quality tier. We're using the pipeline asset underscore high, which means a lot of systems and effects are enabled. And what you'll notice at the top here is that we have a renderer list. We have one custom renderer underscore normal, and another which is custom renderer underscore retro. I'm just going to remove this retro one for the time being. Remove all of the default. Okay, I'm going to switch over to it, and I'm going to remove that. So what you'll notice is that I have on this renderer list just one custom renderer. And I can select this custom renderer. And on this custom renderer, you can notice that we've got a couple of different settings, such as filtering of different masks, there's transparency receive shadows, stencil overrides, and a list here of renderer features. In this case, the water system is using this script will render feature. Now, the water system is using this script will render feature to be able to render the caustics and the depth and all sorts of different features of the water. And if I actually switch in this debug to the caustics, you can actually see how the caustics are actually being drawn underneath the water layer and how they're being calculated. And the blog post I showed you also has a link to a video which goes into a lot more detail in how this sort of caustics are created. If I select this water effects here, you can notice that it shows also the edge that the water is intersecting with the environment. Now if I disable this renderer feature, notice that the water is actually going to be pretty flat. It's basically just a mesh that's then being having noise pass through it and is rippling. But as soon as I turn it on, you can then enable and disable these this water system to then add this renderer feature into your renderer. Now, if I go to this pipeline asset underscore high and it's using this custom renderer here, maybe I want to have a different custom renderer, one that basically has different settings to this one that's set up here. So I'm going to create this now, and I'm going to create a retro renderer, which is going to show how to do things like toon shading and outlines and a pixelated effect, basically using the same project. So if I go into the rendering option, Universal Render Pipeline, and create a forward renderer, and let's call this custom renderer underscore retro. And bring that back up so everything's neat and organized. So I've now got this custom renderer. Now if I go into my high pipeline asset and add a new renderer, I can assign this custom renderer to it. And if I set this as default, notice the water goes back to how it was. So you can switch between these different custom renderers and be able to switch between them not only in this global pipeline asset setting, but also on cameras themselves. So if I select this custom renderer, basically the water's not looking as nice as it did before because it's not using that water system feature. So I'm going to re-add that water system feature. So it's going to look nice again. I'm going to apply, well, I'm going to set up the name for this pass, and I'll show you what this means a bit later on. Notice that we also get some extra settings such as the caustics and how they're being rendered into the scene using this render feature. And what you'll notice here is I can add multiple render features. So I've already got this water system render feature, but underneath here I can then add other ones. So I'm going to add a blit render feature. Now this blit render feature is going to be a toon outline. Here I've got the blit material, so I'm going to search for one, and I'm going to use this outline that I've already got enabled, that I've already got preset up. And this is using the Sobel outline technique with a shader. And if I now, one sec, where was it? Here. What you'll notice is that I've got some different settings here, and also I've got some settings to control on this material. So I can actually set the outline thickness and also the intensity depth. So notice now everything has this like thick black outline around it. And I can also preview what this actually looks like. So you'll notice here, I've got a little toggle on this shader that allows you to then specify render only this toon outline. Now you might have noticed that this toon outline's only being applied to opaque objects such as rocks, the buoys, the plants and things like that. It's not actually being applied to the sky, the clouds, which are just billboard cutouts, or even the water. So if I go back to that renderer feature that I just added, you'll notice here that we can choose different events. So we can actually choose when this is actually rendering or kind of inject it into a specific point. So we can say before after shadows, before after the pre-pass, currently it's rendering after the opaque objects. So if I do this after rendering the skybox, it's going to factor in the skybox into that outline calculation. But maybe we want to include, for example, the water. So let's do after rendering transparents. Notice now in this debug view, we can notice it's actually rendering all the transparent objects. Now, if I go back to my outline and turn it off, let's have a look and see what it looks like. So you'll notice that we've got some nice outlines that are currently being rendered. I can increase the intensity, increase the thickness. Basically, we can now have a nice toon outline shaded boat attack. And notice that this is basically injecting this outline effect without me having to, spend too much time in changing the source code or writing an effect or a system. This is an outline that's available to you, and I'll have a link for the repository at the end of this presentation. And you can see it currently being rendered here. Now, the power of these renderer features is you can also enable and disable them, so you can actually see what they actually look like. So let's turn off the water and turn off the toon outline. So you can actually toggle them on and off, and you can also add more than one. So I've got here this toon outline that's being applied. So another thing to make this game look a bit more retro and a bit more toon-like is to add another blit. And let's call this the toon posterize. And let's go to my toon posterize pass. So what this is now going to do is it's basically going to take this material, which is using a shader graph, and it's going to apply a posterize effect onto the renderer. And it's basically then going to blit it to the screen. So notice that these boys now have a thick black outline, but then as I change this posterize effect, you can see that it's adding different banding onto the boys. So I can actually toggle on and off this effect and actually see how much it's applying to our scene. So it's actually applying quite a lot, and I can turn off the toon outline and return it on. Let's check the game view. Okay, the game view is actually pretty dark, so I'm going to go back to the toon outline and lower down the intensity. And you might also notice that the posterizer is not actually being applied to the water. And again, that's because it's rendering after opaque. So we can actually set this to render after transparent. So now the water is being affected into this posterize, even the caustics. So if I go back to that caustic effect, I can actually see the caustics being affected by this renderer feature. And kind of the point I want to sort of drive home with this is that using these renderer features, you can add different visual styles or adds different visual customizations, and they all work very nicely together. So here I've got three: the water system, which comes with boat attack, a toon outline, which is doing a blit rendered after transparents, and a toon posterize, which is rendered after transparents too. And the last one I want to add is another blit, and this one is going to be called retro pixelation. And let's find that. So this is already in the project. So this is basically going to pixelate the pixelate all geometry. So as you can notice here, we've got this nice sort of like weird retro pixelate effect. People seem to be very, very into doing this kind of technique and style. I'm a big fan of Legend of the Opera Din, or Return of the Opera Din, in games like this. So it's pretty cool to be able to sort of apply this effect into this project. And notice it's rendering after opaques, so I can actually, and so it's not actually applying to the water. So I can actually say, actually render after transparent. So now the water's getting this pixelated effect with it. But maybe I don't want to do that. Maybe I want the water to be a bit higher detail. So let's just do rendering after opaques. So we can then basically customize sort of how our renderer looks. So if I now go into play mode, let's actually play the game and see what it looks like. So we've got the camera flying over the top. We've got all these toon outline, posterization, pixelation effects and things like this. Okay, it's looking a lot more retro for sure. Let's actually play with that outline a little bit. So let's actually change the line depth. And what you can notice is that I've now got this sort of like game set up using these kind of like these renderer features being applied into the scene. Actually, I feel like this should be rendering after the wall. Actually, no, after rendering the opaques. And I can actually switch back and forth. So if I go and switch back to the the original custom renderer, so this is the one with just water, and switch back to the pixelated one that's got the toon posterize. Notice that basically you have that control of being able to switch between these at runtime. So we can actually switch between these effects and switch between these different renderer feature stacks and see what they look like, all within runtime and all within the renderer. Now, the other thing I want to show you is you can also add more custom renderers. So I've got one already pre-made, which is a fog. So this is a gradient fog created at Unity by a developer. And notice that we're using the water system here, but it's a gradient fog script render feature that's been implemented. So here we can set things such as the start distance of the fog. We can set the end distance. And it's just a really nice way of being able to show you that you can actually add in your own features and add in your own rendering tricks and techniques without having to extend the renderer or wait until Unity sort of adds in the feature. You can say, hey, I want to create this gradient fog and then inject it into my project. I can actually say, let's do this after rendering opaques. Okay, that actually looks horrible, but you can see that the gradient fog is being applied to the opaque objects and not necessarily the water. That actually looks quite cartoony, which is kind of cool. So let's actually go back. That fog, I'm not too sure about it being there, so let's render it after transparency. Now, if I go back to my render pipeline asset and switch back to my retro renderer, let's go to the game view. So we got this, and I've got this beauty shot that looks like this. Let's actually see what the frame debugger looks like. So if I now open the frame debugger under Window Analysis Frame Debugger, strategically named, and then enable it, what you can notice is that we've got a couple of passes, including new ones. So I've got here a render water effects pass, which is basically being added. You can see it's also being added here. We've also got the render opaques pass. And we can actually step through these passes and preview what they look like. So notice that there's a couple of new passes in here, which are being added from this script render features here. So we've got the toon outline pass, this posterize effect, and we've also got the retro pixelation, which is being applied after the opaque pass. So we have different settings that can be previewed in the frame debugger. And also, if I now sort of switch one of these passes, so let's say, for example, I turn off the posterize pass, the posterize pass then disappears. If I switch off these different gradient passes, notice that these passes are no longer being added. Now let's turn on the posterize effects pass. Notice it's being rendered after transparency. But if I then move this back up to after rendering opaques, it then shuffles up the stack. So we can actually see from the beginning of the camera render all the way down, we can see render opaques, then render the posterize, then render the skybox and things like that. So as you switch these script render features to different locations in the render order, in these different effects, you can notice them switching up and down in this frame debugger, and you can also preview them. So let's switch back to my slides. So that's kind of a quick overview of the script render features and the system and the custom renderer setup. Now, Universal Render Pipeline also comes with a 2D renderer. This is an extension of the Universal Render Pipeline, and it's a custom renderer. And it allows you, and it uses this system. So where I created that custom renderer and also had the fog and applied it to that renderer list, you can also set up the 2D renderer. And this unlocks extra features. It unlocks features such as 2D lights and shadows, sprite shader graph, 2D mask system, and it also uses some Universal Render Pipeline features, such as post-processing and also shader graph. And you can see on the right here at the top, we've got the Robbie Swifthand platformer project, which is using heavy amounts of 2D lights. And we have here the Lost Crypt project, which is available as well, which uses wind to move the trees and also lights coming through the trees and lots of very beautiful things. So in using the Universal Render Pipeline, and if you've been watching up to this point thinking, oh, it's not really for me for 2D games or 2D projects, you can also use these new 2D graphics features with the Universal Render Pipeline's 2D renderer to make your games really stand out and shine. So the next system I want to talk about is camera stacking. And camera stacking is a highly requested feature. In fact, I think it was probably the most requested feature alongside screen space ambient occlusion. It allows you to overlay multiple cameras. And this allows you to do layered frame compositing, meaning that you can break up your end frame into multiple different cameras that are rendering different forms of content. Gives you individual camera controls, and it allows for modular game development. So you can have someone working on the first person gun while someone else works on the camera rendering the UI. And it allows the combining of systems. So each camera stack can use different custom renderers, so you can use different settings for those scriptable render features. And you can also set up different volumes per camera as well. And I'm going to jump over to this project and demonstrate how this works. So here I have a simple scene, and if I enter play mode, I can then walk around in first person and see these drop ships from different angles, just like a typical first person game. Now, what's not typical about this in a first person game scenario is there are no items. I don't have a gun rendering in front of me or a cockpit or UI or something like this. This is where camera stacking comes into play. Now, what I could do is I could go to the character, which is just here. It's obviously invisible. The character that looks like this, expertly modeled. And we could take this camera that's being rendered and we can put a bunch of stuff right in front of it. But then you're going to have clipping issues and it's going to be like a weird workflow and your artists are not going to be very happy, especially the UI ones. So we want to use camera stacking to be able to render content in front of this camera or as an overlay. So if I select this camera that's being used for this first person view and go to the inspector, you'll notice that there's a new render type and this is called base. And this will automatically be applied if you're using the Universal Render Pipeline. Now, this is a base camera, meaning that you can add other overlay cameras. So I've got up here a cockpit, which has already been set up to be rendered as an overlay. So this cockpit is a little 3D model, 3D modeled by the same person who created Boat Attack. So he's very talented, very multidisciplined and skilled. And with this little cockpit, we want to replicate this as kind of like a mech walker and render this obviously in front of this camera's view here. Now notice that the cockpit has a little cockpit camera. This is using render type of an overlay, and this has all the similar settings that you'd expect a camera to have, such as field of view, projection type, clipping planes, and things like that. And it's rendering only things on the cockpit culling mask, which is this base structure and things like this. So all these elements are rendered on the cockpit layer mask. Now obviously it's not currently being rendered in front of our camera here, so we want to set this up. So if I go to this cockpit camera, notice it's a render type of overlay. So if I go to the first person camera, which is this one, which I'm currently rendering the scene with as I walk around. And at the bottom, you notice that there's this new stack option and the list is currently empty. So if I click this, I can then add the camera cockpit, and this basically scrapes the list of cameras from your scene. This is now going to render as an overlay on top of our first person view. So we've now got this cockpit in place, rendering statically. Well, not rendering statically, it's being rendered here by this camera, but rather than being a render texture, it's now being rendered as an overlay on top of this camera. And the cool thing about this is we can now, for example, select this cockpit camera and adjust things such as the field of view. Okay, that's very Kubrickian, I guess. We can also set up different things like, does this include post-processing, such as bloom that's currently being applied? Does it use occlusion culling and things like this? Does it render shadows or not? And one thing you'll notice is that with post-processing enabled, as you can see here, we can also set up different volume masks. So this has got a volume mask for cockpit, and I can adjust the intensity for these little glowing buttons it's going to apply to this stacked camera. So you can set up different post-processing volumes for different camera stacks. So I'm walking around in my scene and there's a couple of things missing. One is that as I look up and down, notice that the lighting is not really adapting or changing to this tilt. It looks a bit static. I mean, this could be an image technically. So what we can then do is if I go to my cockpit, this is not actually a universal render pipeline feature. I just think it's very helpful for situations like this, is we can actually use the constraint components, in this case rotation. We can constrain the rotation of this cockpit to that of the FPS camera. So, because I still want to have my cockpit up here, so I can have my 3D modeler and lighting and texture artist and things like this, set up all the cockpit rendering off screen, but I don't want it to be following my my character. So with this active now, what you'll notice is that the cockpit now tilts. So as I, let's actually split this. So notice as I move around, and let's zoom in here a little bit. As I look around in my bottom view, notice that all the lighting is adapting onto this cockpit, but then it's still being rendered by this camera stack here floating in the air. Very handy. So that's got a little cockpit in place here. So let's actually add UI. So UI is obviously another massive part of pretty much any game or any interactive project. And here I've got this danger, shield, health UI that's being rendered to its own UI camera. This canvas is currently a render mode of screen space camera. That's a bit of a tongue twister. And it's being rendered by the camera UI. Now we want to stack this UI as well because we have the cockpit camera and we also have the UI camera. So if we go to this UI camera, notice it's using a render type of overlay. And if I go to this FPS camera, we've already got this cockpit here, cockpit camera, that's apply a UI camera, and it's now being stacked as well. So we've now got this little cockpit walking around with shield, health, danger warning sign with some particles being rendered to that UI camera. And it's basically being stacked as well, including lighting adapting and using the lighting or from the same tilt as the FPS camera. So we've now got our cockpit and our UI being stacked on top of our first person camera. And of course, as you have these different stacks, you can then rearrange them. So if I then move the camera UI up in the stack, it's now being rendered behind this cockpit. So we're rendering the UI first, and then we're the UI camera first, and then we're rendering the cockpit camera. That's obviously not realistic, but I want to switch these around just to show you can move these stacks about. Now, if I select this camera UI, this UI camera, notice that it's got slightly different settings. So for example, it's not using post-processing because the post-processing, we're currently using Panini projection to be able to warp the camera. But we don't want to use this on the UI, so we can turn this post-processing off. We're not rendering shadows to the UI because that kind of doesn't make any sense. And we can also do different settings such as field of view. So let's make the UI really stretched. Okay, it basically looks like the Star Wars opening scene now. But you basically have these different camera settings per stacked camera, which is very powerful and very, very useful in a production like this, or in a scenario like this. The other thing I want to show you is kind of like a universal render pipelines system similar to UsePass and GrabPass. So if I enable this screen, and this screen is basically just a mesh that's being rendered inside the cockpit, and as I look around, I've then got this little screen with these different panels which are glitching out, and these are all glitching using shader graph. But what you'll notice is that shader graph is actually taking the image on the other side of the screen, or the camera's render, and it's then basically then applying this glitch effect on the left, on this little CRT scan lines on the bottom, and this more black and white striped effect on the right. And if I go down to these the materials being used for this screen effect, I've also got like an invert colors, so I can actually invert the colors for the middle thing. So it's basically taking the image and it's manipulating it some way. And this is quite common for a game where you have a cockpit or some kind of screen where you view the world through, and you want to apply these different effects. This is done using, this is similar. Basically, you would use UsePass and GrabPass before to create an effect like this. You know, if you want to like blur the middle image, or you know, take the middle image, or adjust the seeds, or I don't know, invert the colors and things like this. Now, use pass and grab pass aren't in the universal render pipeline, but we can use different other tricks and techniques. So if I go to the renderer, which is that render pipeline asset, notice here we have an option called opaque texture, and this is turned on. And what opaque texture does is it allows you to grab the objects being rendered in the opaque pass and then use that texture for different effects. And if I select that screen, notice it's using a shader graph. So if I now open this shader graph, and it will open. Now I won't go through every node because that will probably take quite some time. But if I go to the, whereabouts is it? Scene color. Okay, so the scene color node, what this does is this uses the render pipeline's opaque texture, which is basically drawing all the opaque objects into a texture in the opaque pass. And scene color and shader graph, this node allows you to get that UV and then output that color. So you can kind of use it like an X-ray or like a screen fade or something like this. Or in this case, these very glitchy effects. So these screens are using that opaque texture and able to create this glitchy effect without having to actually, you know, write any code at all. You basically can use this shader graph scene color node, and there's also a scene depth node, and basically be able to sort of create these weird glitchy effects using camera stacking and using all these different features and systems together. Of course, you can do it without camera stacking, but this shows that you can render the opaque objects of the main camera as a texture and then apply them into this other stack. So this end frame is basically a composition of lots of different features and tools. Now, this is all pretty cool, but another thing that a lot of people ask in how to make is first-person controls. So here I've got this little first-person gun that's being rendered in the scene world. And this first-person gun has a camera gun renderer. And you can see here in this preview that's basically then just rendering the gun and the skybox behind it. Now, similarly, what we can then do is then go to the first-person camera. I removed the stacks from this because I left play mode. And then I can add the camera gun renderer. So we've now got the camera gun basically rendered as a camera stacked overlay. And a lot of people ask, you know, why would you do this? And it's basically so that you don't clip through geometry, because now I'm inside the dropship. I didn't add colliders. And what you can notice is that the gun is still being rendered on top of the ship, as opposed to clipping through it. You know, at this point the nose would probably be, if I actually go down, the nose of the gun would probably be directly inside the dropship, and that's not actually accurate at all. Now we have this gun renderer that looks like this, and notice it's automatically not clipping because of the camera stack. But we could also get some extra controls. So for example, we can actually change the field of view of this gun renderer. So I can actually like sort of make it a more zoom view, and I can also control things such as, you know, does post-processing effects like the Panini projection also affect this gun render here. But another super cool thing you can do is with camera stacking is you can actually choose these custom renderers and apply them to different cameras. So remember when I showed you the retro renderer and then the gradient fog renderer? Well, it's basically the same concept. We have this custom renderer default, which is actually pretty default. It hasn't actually really got anything turned on. And we've got the custom renderer underscore gun outline. If I open up the gun outline, it's going to have its own scriptable render features to render an outline pass on the gun specifically. So if I go to the gun camera and then choose that gun outline, notice it now has this outline. And this would be similar to a game like Overwatch or maybe even League of Legends, where they have an outline outside around the characters. So you can actually use camera stacking. So we've got a stacked camera of this gun using its own custom renderer. And then we've got the main scene using a different custom renderer as well. So you can combine scriptable render features with camera stacks and sort of combine them in sort of different ways like this. And the other really cool thing you can do is different effects that allow you to use these different camera stacks and use these script render features for quite common gameplay scenarios or graphic scenarios. So I've got this terraformer, or I have 3 terraformers actually, and these are all enemies. And currently, they're actually quite big compared to the dropship scale. And these enemies are currently just standing here. And I can't see them through these walls, but quite a common aspect of through these dropships, sorry. But quite a common aspect of any kind of first-person shooter is being able to see your teammates through walls, or maybe you get an ability that allows you to see your enemies through the walls. And we could do this using script render features as well. So we're not going to apply this to the gun outline, because the gun outline is just basically using the render objects render feature, as you can see here, render objects. And it's basically applying this toon outline to anything with first-person objects on the layer mask. So we're going to go to FPS default, because we're pretty much going to assume that anyone using the FPS camera is going to want to render the enemies. And I'm going to use the same render objects script render feature. So if I enable this render objects script render feature, what you'll notice is it's basically going to, after opaques, render in the render queue of opaque, go to the layer mask of any enemy and render using this enemy X-ray material if the depth test is greater. So notice you can now see these enemies with this kind of weird glitchy effect that I've created in Shader Graph. And you can see them through the walls. They're basically always being rendered, because it's being rendered when the depth test is actually greater than these dropships. So we can see them through the walls, and this is pretty cool. So we've already got, using the script render features, we can already set up, a first-person shooter with this kind of graphics functionality. Now, obviously, this doesn't really make much sense when you have the X-ray seeing them through the walls is actually rendering on top of the character, although I think it does actually look pretty cool. So we've got here an enemy shaded pass script render feature. So what this does is it allows you to re-render the enemies on this layer mask of enemy. So now we're basically re-rendering the enemy. So now if I look through the dropship, if the depth test is greater, it renders the X-ray effect. And if the depth test is not as great, such as we can actually see this object on the enemy's layer, we can then see their shaded pass. And of course, with all these different things in play, if I open up the frame debugger and enable, you can see here we have the enemy X-ray pass, we have the enemy shaded pass, we also have the opaque pass, the rendered opaque pass, the transparent pass. We've basically got all these different passes, these custom passes and things like this, all basically viewable in the frame debugger. So you can actually see when they're being shaded, or if they're being shaded at all. So we have the opaque pass, then the X-ray, then the shaded, and then the skybox pass. So we can view all these script render features and all these different camera stacks and see them all working together very nicely in a couple of different scenarios and a couple of different ways. So I jump back to my slides. So let's talk about the future. So those things that I showed you, script render features and the camera stacking and these custom render passes and things like this, are all things that are available to you right now. I was using 2019.3 for all of them, and all those examples I'll share in a slide in a second. I'll link you to the GitHub repos and you can download them, and there's a lot of other interesting tools and features in those projects. So let's talk about the future. Let's talk about some things that are coming out soon. So one thing that's under heavily development is Screen Space Ambient Occlusion, or SSAO for short. This is another highly requested feature, similar to script render features and also camera stacking. And as you can see on the right here, we have a GIF that loops through this nighttime scene. This is not using SSAO. And we also have this half shaded scene. This half shaded scene is using SSAO on the right in Boat Attack. And this is going to be implemented as a script or render feature, just like the water system, just like that toon outline, the X-ray effect and things like that. And you're going to have control over global settings such as how much it's being blurred or how wide it is and the intensity and things like this. And it's a very cool and very powerful system. Also working on deferred renderer. Currently, Universal Render Pipeline uses a forward renderer, and deferred will be an option that's going to be available in a future release. And this nighttime scene is using an early version of that deferred renderer. As I said earlier in this webinar, we use Bototac quite heavily to test or use as an example project for new features and things. So that's why you see SSAO and also the deferred renderer in use with this project there. We also have shadow mask support being added. So this is going to add extra features and functionality for shadows, as well as a clear coat, which isn't being applied in this GIF at all on the boat, but clear coat is quite a common request for things like shiny materials or more glossy surfaces, such as on like cars or vehicles like that. Also reflection probe improvements, such as blending and also box projection, and that will allow it to bring Universal Render Pipeline up to more graphics feature parity in the reflection probe areas to the built-in renderer and also HDRP. And also shadow improvements. Masks I've already mentioned, but also things such as distance fall off. So pretty much all the features that we have released recently, such as scriptable render features, custom render passes, camera stacking, screen space ambient occlusion, and things like, and all the things we're working on are all heavily requested from our community and our users. You basically are the bread and butter of why we create all these tools and example projects. And we want to drive Universal Render Pipeline and Unity in general to align more with what you want to achieve and how you want to achieve it. I can also say that we're also working on some exciting new example projects. So we already have the Bototac project and the other examples I showed, such as the cockpit demo, and things like that. But we're also working on some new Universal Render Pipeline, both 2D and 3D examples, which are going to show other different types of scenarios, other different types of uses. So we're heavily invested in the Universal Render Pipeline and its future, and also in making it basically the most powerful render pipeline, not only for desktops, but also for mobile, AR, and VR, and consoles, of course. Here are some links to the example projects. So Bototac is a has a GitHub repository, which you must clone because it uses Git LFS. Everything I did in the webinar, such as gradient fog and the posterize effect and the retro effect and things like that, is in this branch of demo/webinar-unite now. So you can go and download that branch right now using 2019.3, or you can just download the root or the master of the repository just to get Bototac and dissect how it looks, or dissect all the different systems and tools it offers. We also have a Universal Render Pipeline examples. So we have a GitHub repository which has a wide variety of different examples for you to use, such as the Toon outline, the gradient fog example, the cockpit camera stacking demo, first person render, and things like that. Everything I showed there is in that repository or can be created using that repository. I just used that repository and then added a couple of little shader graphs and effects and things like that. So we have these different resources which we're going to keep maintained and also update in the future with new examples and new scenarios. We also have this blog post which I highly recommend you read. And this is basically written by Andre McGrail. He is the tech artist and developer of Bototac and a lot of the universal rendering examples as well. And he goes through more specifics on how he created different things, such as the shader graph for the wet rock in Bototac, to the water shader, to planar reflections and things like that. And I highly recommend you read that blog post because it's very insightful in how to take your universal render pipeline projects to really the next level by adding all these other features and functionality and tooling that he offers with the Bototac project and with his knowledge in that blog post and video. I hope this was a helpful webinar. I hope the examples were helpful as well. This is part of the Unite Now webinar series, and we're looking into doing more of these in the future, focused on graphics and the universal render pipeline. So if you do have any requests, you can reach out to me or reach out to us on the forums. I hope this was very helpful in helping you choose in how the Universal Render Pipeline can fit into your projects or how the different features can be used. Even if what I showed you doesn't necessarily align directly with what you're making in terms of genre, hopefully the scriptural render features, camera stacking, and the tools that we're working on can allow you to kind of achieve your graphics goals and achieve your graphics visions. And we're, of course, always open to feedback. So thank you for watching. And if you have any questions, I'll be hanging around in the chat after this stream, and you can ask them to me there. Thank you.